Guys, I want us to engage on the paper that was written yesterday for physical sciences paper on grade 12, just to assess and check as to was it fair or was it not fair, was it that much difficult or was it simple. So we'll start with question 2. On question 2, of course, they were examined based on forces, which is Newton's law and its application. They were given a statement there. They said a block of mass 5 kg is at the rest on a rough horizontal surface. So since the learners were told that the surface is rough, of course they were expecting the presence of friction force. It can either be static or the kinetic frictional force. Now they said when a constant force F of magnitude 18 Newton acts on the block at an angle theta to the horizontally, the block experiences a maximum static friction. So they were given the maximum static friction, full stop. See the diagram below. So there it's the given diagram. It was very simple and straightforward where they were having a 5 kg block. There it's the angle theta, there it's the constant force that is applied on the 5 kg. And then the first question for 2 marks, which was freely given to every learner who was writing the final examination yesterday. They said state Newton's second law of motion in words. So the second law states that when a net force or a resultant force is exerted on an object, the object will accelerate in the direction of the net force at an acceleration directly proportional to the net force and inversely proportional to the mass of the what? To the mass of the object. So those 2 marks were freely given to each and every candidate. And then 2.2 for 4 marks, they said draw a labeled free body diagram showing all the forces acting on the what? Acting on the block. So now we are answering that one. We'll be saying 5 kg. Mind you, they will ask to draw a free body diagram. So the object of interest is represented by a dot. There it's the object of interest. So now we all can see that the first force experienced by this 5 kg, of course, it is experiencing what we call the weight or the gravitational force. That's the first force. So each and every candidate was given this 1 mark. And then the second force experienced by this, of course, now this one is experiencing what we call the normal force, the force exerted by the surface on an object in contact with and always act perpendicular to the surface. And then the third force, of course, the applied force that is applied at what? That is applied at an angle. So there it's the applied force, the F, which is equivalent to 18 Newton. So that's the F for the free body diagram. And then now the last force that is experienced by this one, of course, we've got what we call the static, since we are told the 5 kg it's at rest. So this one, it's experiencing the maximum static frictional force. So this is how you were supposed to give or draw your free body diagram for 4 marks. It means as I'm speaking right now, each and every candidate is now having 6 over 17. Now the 6 over 17, let's calculate the percentage of the 6 over 17. I've misplaced my calculator. Unfortunately, we're going to just calculate the percentage of the 6 over 17. Now let's check the 6 over 17 as to it's how many percent. 6 divided by 17, of course, it's 6 divided by 17 multiplied by 100. So 2.1 and 2.2 was taking each and every candidate to 35.29%. You see, it was very fair. And then 2.3, they said to us, the horizontal component of Earth is 15. So now, what is it that I'm going to do here? let us resolve this one to its component. So when resolving to this one to its component, basically we'll have something of this nature. There it's our F, which is equivalent to 18, and then we are told that the horizontal component of each here, it's 15 Newton. That's what was given on the statement. Then now we know this one, it's 18 Newton. There it's our angle, there it's our angle theta. Then we can be able to resolve this one. Remember this one, it's your F bar, your Fx. So we can construct our Fy there. There it's our Fy. So we have resolved the applied force to its two components, which is the horizontal component as well as the vertical component. And then now they say to us 2.31, we must calculate the angle theta. So they were looking for the angle theta again for how many marks? For 2 marks, which was also Fred. So in finding the angle theta, this one, we will rely on the right angle triangle where we're going to apply the trig ratio. So what is it that we are having? We are having the opposite of the angle, which is Fy, and then unknown, having the adjacent of the angle, which is what? 15 Newton, having the hypotenuse of the angle, which is what? 18 Newton. So the correct trig ratio that we can apply here, of course, will fall for what? Cos of theta equivalent to cos of theta. It's defined as the adjacent. So our adjacent in this case is our Fx over our hypotenuse, which is what? Which is our F in this case. And then from there we correct substitute everything. So we are looking for the angle theta, and then our Fx here it's 15, and then our F is what? It's 18. So then now we know that each and every candidate, of course, must be given 1 mark for doing this. And then now from here, as we make theta the subject of the formula, of course, shift cos will take us to this thing in your calculator so that we can find the angle. So we are saying shift cos of the angle, which is giving us 15 over 18. Now let's look at this one. 15 over 18, it's taking us to what? 33,557 degrees, which is the what? Which is the angle theta. So your theta is 33,557 degrees. So there's another tick for finding the correct theta. So at this point, as I'm speaking, we are expecting each and every candidate to be at 8 over 17, because this question was just fair and very simple and straightforward. And then our 232, they said we calculate the coefficient of the what? The static friction. Right. So in finding the coefficient of the static friction, what is it that we're going to do here for 5 marks freely given? Now let us draw a solution diagram. It is going to assist us. So in drawing our solution diagram, in solving this problem, what are we having? We are having this Fx, which is the what? Which is the horizontal component of F. And then again, what is it that we are having? We are having our what? Our Fx. So this is our solution diagram. And then from this solution diagram, we can say if we let this one, we let right to be positive, we let right to be positive, it means our left must be what? Our left must be negative. Now mind you, we are told that the block of mass 5 kg is at what? It's at rest. So since it's at rest, basically they are telling us that the acceleration of the 5 kg it's equals to what? It's equals to 0. From there, since we set the right as positive, then it means left it's gonna be what? It's gonna be negative. Then we apply Newton's second law of motion. In applying Newton's second law, we know that our F net is equals to what? It's equals to ma, which is the correct formula for us. Then our F net it's equals to the sum of these two, but taking into consideration the what? The issue of the direction. So in this case, we will be saying together, we'll be saying minus Fx, of course, right? Plus our minus Fx plus our Fx, it's equals to 0, because the acceleration now is what? It's 0. And then from there, mind you, what is it they are looking for? They are looking for the what? For the coefficient. And then from here, we can break this down, right? Let's break this down. As we break this down, now we know that this is going to be minus into one, okay, minus mu s multiplied by the what? Multiplied by the normal force. Allow me to put everything inside there. And then this one, thank God, it is given. Now everything is equals to what? Everything is equals to 0. Now let us take that to that side. As we take that to that side, so that this one will be positive. Allow me to say my Fx is equals to what? It's equals to a mu x the mu S, of course, and then the normal force. When finding the normal force, we know the basics. Our normal force in this case, it's going to be equal to what? Our normal force, it's equal to the gravitational force experienced by the 5 kg. Now, we are subtracting the what? We are subtracting the Fy, which is the vertical component. So your normal force in this case, we are saying normal force is going to be gravitational force minus your what? Minus your Fy. So then now this one we know from this point that allow me to plug this equivalent to, okay, there's normal force there, and then it means our mu S, it's gonna be what? It's gonna be the gravitational force minus what? Minus your Fy. Simple like that. Mind you, we are looking for this. This is what we are looking for. Since we're looking for this, now let's divide everything. In this case, allow me to divide everything by this. Let's divide everything. Okay, let us not divide. We can divide. Let's divide everything by the gravitational force minus your Fy divided by the gravitational force minus your what? Your Fy. So that this will cancel that. Yes, we are moving. So that will cancel that. At the end of the day, what is it that we are left with? We are left with what they are looking for, equivalent to our Fx over our gravitational force minus what? Minus our Fy. So we do correct substitution on what we are having up there. As we do correct substitution, everything is given there. We are given our Fx, which is 15 over. Now this one is going to be 5 multiplied by 9,8, which is the what? Which is the gravitational force experienced by the object minus. Then now we manage to find the angle theta, or we can even use the what? We can even apply the Pythagoras theorem in finding our Fy, where we've got this side, the adjacent, we've got the hypotenuse, then we can find the what? The vertical component. But allow me to say the Fy is equal to 18 sine of what? Sine of 33,557. So that we punch our calculator, then we can find what they were looking for yesterday. This paper was very fair. Now it's 15 all over. What are we having? 5 multiplied by 9,8 minus 18 sine of what? 33,557. Close. What are we getting? So our coefficient in this case is 0,384. So this is how you're supposed to attempt such a question. Again, the 5 marks was freely given to each and every learner. It was freely given to each and every learner. Now let's look at the last question, which is what? 2.4. This was the last question for 4 marks. Again, they said the angle theta is decreased, right? While the magnitude of Earth remain constant. Right, let us check. The normal force before decreasing the angle theta. Mind you, our theta is 33,557. So the normal force before decreasing that, let us find the normal force together so that we'll know what is the normal force before decreasing that. So our normal force in this case is going to be 5 being multiplied by 9,8 minus 18 sine of what? 18 sine of 33,557. What is it that is giving us? So the normal force before is 39,050 Newton before decreasing the angle. So together, let's go and decrease the angle and see as to what is it that we're going to obtain. So we're gonna take this one. Let's decrease it to 20. 20,557. We're just decreasing the angle so that we can find the new normal force. From there, we'll be able to see as to what happened. So we are having 5 being multiplied by 9,8. Being multiplied by 9,8 minus 18 sine. We have decreased the angle to 20,557. Let us see the new normal force. So the new normal force, it's 42,67. All right, let us analyze everything. The question is saying to us, how will the friction acting on the block be affected? Choose from increases, decreases, or remain the same. Explain the answer for 4 marks. So basically, they're asking us as to what will happen to the static frictional force or frictional force as the angle decreases. So then now, what is it that we have observed from our analysis? We all can see that the normal force has changed from 39,050 Newton to 42,67 2.67, meaning the normal forces, that's what? The normal forces increase, meaning decreasing the angle increases the what? Increases the normal force. That's the first thing that we have observed. And then from there, we know from the equation that this coefficient, it's equivalent to what? It's equal to, mind you, before we can get there, we know that this, it's equals to that we know. The static frictional force is equals to the coefficient multiplied by what? Multiplied by the normal force. So let us make the coefficient the subject of the formula. So everything shall be divided by normal force. It means the coefficient is going to be the static frictional force over what? Over the normal force. So then now we know that this coefficient can only change once we change the what? Once we change the surface. So at a constant surface, if we do not change the surface, now it means the static frictional force, it's directly proportional to the normal force, meaning as the static frictional force or as the normal force changes, it can either increase or decrease, then the static frictional force will also change by that factor. Simple like that. So in this case, we all has observed that the normal forces, that's what has increased. So then now they're asking us as to what will happen to this one. Now the correct answer, our correct answer is going to be what? Increases. So each and every candidate was supposed to opt for increases. Then there's 1 mark for what? For increases. Then they said we must fully explain. The second tip, every candidate was expected to say decreasing the angle results into an increase in the what? In the normal force. The first tick, increases. Then we are explaining for 3 marks. The second tick, each and every candidate was supposed at least to have said in decreasing the angle theta will result into an increase in the what? In the normal force. Tick number 3, as the normal force increases, it will result into an increase in the what? In the static frictional, in the what? In the static frictional force, or the maximum static friction. As the normal force increases, it will result into an increase in the what? In the maximum static friction. So then now you can say, according to this equation, then we can conclude that according to this, our static friction is directly proportional to what? It's directly proportional to normal force. So this question 2, according to me, it was very fair to each and every candidate who was writing the final examination yesterday, meaning 17 marks was freely given to all the candidates. Thank you for watching. Please follow me for more. Please subscribe on my YouTube channel, Unfolding Science with KV89. Please follow me as we proceed to do other questions. Question 3, question 4. We'll keep on discussing the question paper. Thank you.